Hi and welcome to the second tutorial in the Simple Shooter series. Um, so in the first part I showed you how to replace the model that's used for the robot in the example projects provided by Lumberyard. Here we're going to make changes to the C++ code to allow us to fire projectiles or rockets from the turret when the left mouse button is clicked. Now you don't need to have done the first tutorial for this one, it just won't look as good, I think, because you'll be firing from a robot and not from a turret, but that's up to you. So you don't need to have done the first tutorial for this one, and this is more aimed at people who like to code in C++. You could achieve the same results using flow graph. I just like to work with the code. So I think, actually, speaking of flow graph, let's look at some flow graph, and maybe a kind of a general hint is that, so you don't need to follow these steps for the tutorials, just to show you some ideas. If you add a node, for example an entity, spawn entity node, then you can get good results very easily. If you want a lot of flexibility, and if you want to include that flexibility in your code, then it's useful to look in the code base for how this is implemented. Okay, so the way I do that is I look at the name of the node here, entity spawn, and then we go into our into the code, and you press Control Shift F to search for a string. So for example, if I search for the string we just saw there, which is entity colon spawn, entity colon spawn, and if you look in the entire solution, find all, then we'll see that there's a file called flow entity node.cpp which contains the implementation of that node. So let's go there and check how it is implemented. I can use Control F or edit find to find how it's implemented. And if I scroll down, I'll see the code which is used to spawn an entity, and the line is this one here. So spawn entity, and to spawn an entity you need to provide certain parameters. You provide the name of the class of the entity you want to spawn, the position you want to spawn it at, the scale, and so on. You can also provide a rotation for it. So that's how I learn how to code here. I look at examples from the code base, in particular from flow nodes, like the one we just looked at, and then we just include that code ourselves, which is what I'm going to do over here. Okay, before we do that, the first change I want to make is in the actor.h file. So we're in the samples project in the solution. There aren't that many files in here. We've got 1, 2, 3, 4, 5. We've got a handful of C++ files in here, and we just make changes in 1 or 2 of them. So in actor.h we want to make sure that the actor is a listener. So we'll extend iActionListener by adding comma public iActionListener here. So it means that our actor will derive not only from game object extension, but also and from game object view, but also from the iActionListener. So that's a simple change that we need to make here, and that will ensure that the actor will respond to keyboard inputs and to mouse clicks and so on. Now we need to implement a function called onAction. So that's we put that into the set of public of functions for the actor class. The implementation then is in the active CPP file. So just double click on that to open it up and scroll down to the end of the file and add the onAction function. And the implementation I have here is such that when the left mouse button is pressed, we will spawn an entity very much like what we just saw. So the code you see here is pretty much like it's a copy of what we just saw in the flow entity node class. So that's how you can help yourself, if you like, when you're trying to figure out how to do things in code. So really what we're just doing here is we're saying, well, we want the bullet or the rocket that we fire to fire in the direction that the camera is facing. So first of all, I get a reference to the camera, and down here then I get a reference to the player as well, which is the robot, and then we calculate the position of the bullet based on the player's position plus an offset, which is just a little bit along the line of sight of the camera view, and then I add a vertical offset as well. So this is basically just getting the initial position of the projectile, and this is what we then set to the V position. Then a couple of ways you can actually define the entity. You can use find class and then the name of an entity that you'd like to use, or you can use default class and then later load a geometry into the entity. The key line here again is the spawn entity line, and then to move the projectile once it's been spawned. So if I just added the code down to this line and didn't add this code here, then the bullet would be spawned but it wouldn't move. So to move it, we need to physicalize the entity using this line here, and we do so with certain parameters. So for example, we give it a mass of 10, and then to actually move it, we use the action function on a physical entity. So it's a little bit complicated maybe, but the idea here is that you get the physics of the entity, you create a velocity struct like this. You set the velocity of that to be along the direction of the camera times some multiplication factor. That's the speed, and then you apply an action to your physical entity. And the last piece here then is to create a trail effect. So the particle effect, and this won't work with the demo, the samples project as it's delivered. You'll need to copy over some materials and textures from the legacy game SDK project. I'll show you where to get that in a minute. Okay, so I think it's probably not a bad idea to first of all start off by copying code in, and then over time looking at the various pieces, asking questions and checking how it all works. One of the best ways to learn as well is to play around with some of the parameters and values and check the effects in the game. So for example here we could load a different mesh, and then we would fire not spherical bullets, but potentially then rocket shaped bullets or similar. You could change the mass, we could change the initial speed. I just added 1,000 there, so they'll go much more quickly. You could add more than one effect to it. You just need to load a different slot here. This is adding to slot number 1. Okay, so that's the change that I needed to make in Actor CPP. I also needed up here to, for that to work I needed to, I think, include a couple of other include files, a particles.h and a component physics.h. that was necessary for the code that I added below. And then, okay, so in the post init function, you'll need to also add this line here. If you don't, then the on action function won't be called. So it's not enough that the actor class is an action listener by deriving and implementing the action listener interface. You also need to add this line here in order for the on action function to be called. Now the question about why, how this works here, the mapping between an action and the string fire, that happens in a file called actionmaps.xml, which you can find under config input. And so I added a line here which links the string fire, which we saw in the code a minute ago, to the mouse. So when you use mouse 1 here, that means the left mouse button. So that's the link between actions, the string that we saw before, and the various keys and mouse clicks and so on. So for example, if I wanted to react to the left, to the A key, then I'd need to use the move left string in the code. So in here I would say something like, if action is equal to move left, do something, right? But I don't want to do that here. There are flow graphs nodes already which handle the left and right and forward and back movement. So this is just to show you how you can use code to implement something when the left mouse button is clicked. The other thing we need to do is we need to create some kind of effects and explosions when a collision happens. So to do that, we can go into this file here. So that's gameplay sample game rules.h, and add this line. So we're going to implement the on collision function, and we do so here in the CPP file. Basically, in any collision there are a couple of entities involved. You can access the entities through event.pSource entity and event.pTarget entity. And what I'm doing is I'm just taking the names of those entities and assigning them to strings. One is called first collision object name, and the second one is called second collision object name. And then if the first collision object name is bullet, so you remember over here in the actor class we named the entity which we spawn bullet. So if one of these, if the first one is bullet, then we'll create an explosion, and we'll hide the bullet. What I want to avoid is that if they're both bullets, that you get a lot of explosions when the bullets hit each other. Okay, so just want to have this to happen, this effect to happen when the first one is a bullet and the second one isn't. And that's it. So I'll close this down and we'll run it again one more time. So that's it. You can fire the bullets, and in the next tutorial I'll show how to add enemies that you can fire at. Alright, so I hope that helped. Thanks.